Hello guys, so it's been a long time, quite a long time since I've done one of these. Initially I planned to do a stream today, but as you can see, Cheyenne is already doing one of those. So like I didn't want to, compete with anyone. Let him do this one. Yeah, so I thought why not do a recorded one? And I think this format is sort of like the best format because a lot of people ask me how do you, figure out which technique is to be used. For example, like in some problem, how do you figure out if it's FFT or like DP or something like that? So I think for that, this format is sort of like the best because like you can actually see how the intuition is being built. So like what I do in one of these videos, what I do is I sort of read the problems during the video itself, and then I kind of try to figure out how to solve it, and I actually write the code while thinking out my thoughts out loud. So I think it can really help you as a viewer to sort of build that intuition, like how to figure out how to solve a problem or stuff like that. So I think that would really help. And yeah, let's just get into these problems. So I think I am already 7 minutes late when I started, and then there are already 10,000 submissions on the first problem. But I think we'll be fine. So I'll do this thing. I'm not sure if it worked, but yeah. So I have some sort of extension which creates stubs for all the problems in the contest, and then brings the test cases as well as the expected output. So what I just need to do is write the code, and then I can just run it here itself and verify if my output is correct or not. So yeah, let's start with the first problem, ideal generator. So okay, so we have an array with the of size k, I guess. Okay, we don't have the array, we just have k. And okay, right. So they're just explaining what is a palindrome array. I think that should be easy for most people. Okay. 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 Right. Okay. So I think right. So I think what they want us to do is they want us to have they give us k, and then they want us to sort of have an array such that like if you like that array has to be palindrome, and if you add up all the elements of that array, you are I think you can get like any number basically, any number greater than the length of the array itself, because then you see all elements must be at least one, so that itself will be k. And like if you remove that restriction, if like elements are allowed to be zero, then basically you have to make any number from zero till infinity. So I think it always works for odd numbers, because like in the central element, because the central element can be basically anything. And yeah, I think that works because then you can put anything there. And for even, it never works because you cannot make an odd number with even number of elements, because two of the elements are equal and it must be even. So it's just an odd even thing. So I'll just take the test cases. For each test case, I'll just solve it by taking k as input, p in k, and if k mod 2 equals 0, then I see out no. Otherwise, it's just yes. Okay. Okay. So all the local test cases passed, so I think I can submit this one. I'll just go to this thing and submit it. Okay. It's in queue. Right. So I think before moving to the next problem, I kind of want to explain how this one worked. So like, okay. Yeah. Okay. So it's just that you have an array and you want it to be palindrome. So you can see that if it's an even length array, then these two elements have to be equal and these two elements have to be equal. So then the sum will be sort of like the sum of these two elements multiplied by 2. So it is always even and never odd, right? So it's basically never odd. So any even length array will never work because you can't make odd numbers with it. And then you can see that if you have an odd length array, then what you will do is you will put ones here in the all the indices except the central one, I guess. And then in this index you can put anything. You can put 1, 2, 3, 4, anything, right? So basically you are able to get any sum. Yeah, so that's the idea behind this problem. Now let's move to the next one. Okay. Right, so this is the second problem. Let's see how many submissions are there for this one. Okay, now it's 2000 because more time has passed. So anyway, the cost of a number is defined as the result of dividing the number by the sum of its digit. Okay, so like for 104 it is 20.8. We are not even truncating it. We want to keep the fractional answer. Okay, it has no leading zeros. You can remove any number of digits from the number including none, so that the remaining numbers contains at least one digit and is strictly greater than 0. It cannot be rearranged. You may end up with a number that has leading zeros. Okay. Right, so I think leading zeros probably won't matter, right? Anyway, what is the minimum number of digits you need to remove from the number so that its cost becomes the minimum possible? Okay, so the number has, I think, up till 100 digits. So you want to remove some digits so that the cost becomes minimum possible. Okay, my first intuition is that it's probably like you have to, I guess, remove all the digits except zeros, or you can't remove all the digits. Like if it has zeros, then okay, you need the remaining number to be strictly greater than 0, right? So you cannot remove all the numbers except zeros because you don't want the remaining number to be strictly greater than 0. So I think right, so what we can do sort of here is right, I think we can easily get the cost to be 1 because we can remove all the digits except one of the digits. Like we can have just a single digit and then that divided by itself will be 1. So the cost can be 1. I just want to see if the cost can be less than 1 or not. So it's like if we have 2 digits, then it's like 10 into a plus b upon a plus b. So yeah, I think that is always greater than 1. So the minimum cost that you can get is, I think 1 is the minimum cost that you can get, right? 1 has to be the minimum cost that you can get. So all you have to do is you have to find what is the minimum number of digits that you need to remove to make the cost 1. And if there are no zeros in the number anywhere, then I think you have to remove all the digits except any one of the digits so that the cost becomes 1. And if it has any zeros, then let's see what you have to do. Then I think you can keep all the leading zeros and remove everything else, right? So I think all you can't remove is the trailing zeros. So you have to keep all the trailing zeros and then you have to keep one more digit and remove everything else. So like we can scan the number from right to left and find the first non-zero digit, and like that many digits you must keep. So all the others you can remove. So like from here, you have to keep one. I have to keep, I think, three. Let me see. No, I think I said something wrong. I must keep three, so I think I can remove. No, okay. Sorry, I must remove these digits and then keep this one and um, remove everything else except the leading zeros. So I think for this one I have to remove 4, and for this one I must remove this leading zero, and sorry, I must remove this trailing zero, and then all the other zeros I can sort of keep. So I'll keep 0, 0, 3, and I can remove 1, 2, and 0. So I can remove 3 of them, right? So I think I just need to count the number of zeros and the number of trailing zeros, right? And I think that's it. Number of zeros minus the number of trailing zeros. Basically, these many zeros I can keep along with one more digit. So it's like 1 plus non-trailing zeros, right? So I have 2 non-trailing zeros plus 1 is 3 minus 3, and I have no non-trailing zeros, so it's 1, 5 minus 1. Yeah, I think that works, right? So I can take this input as a string because it won't fit in the int because there are too many digits. So yeah, and then I just need zero count, right? So I can go like okay. So now I know how many zeros are there, right? So basically I can keep all of these. So like int to keep equal to 1 plus the whatever zero count, and then I can remove all the trailing zeros, right? So I need the trailing zeros. So like I think I can do it something like this: while s dot back equal to 0, I can just do trailing zeros plus plus and s dot pop back. Like from the last I can see how many zeros are there. So now I need to keep like I can keep at max one digit plus all the zeros minus all the trailing zeros, right? So I must keep these, so I must remove so like I have to keep these, so I must remove right. So the length equal to s dot size, so I must remove length minus whatever I have to keep, and then I can just do how many I have to remove. Let's see. Yeah, worked on local. Let's submit. Oh, wow. Oh, I thought I would have to, tell how many dogs are there in the picture or something like that. I hope this is correct though. But yeah, should I explain the previous one? I think the code is kind of self-explanatory. We have to keep, we have to remove all the trailing zeros. We can keep the rest of the zeros, and we have to keep one of the non-zero digits, and that's it. Should be correct. Yeah. No need to explain that one. Like we can directly move on to the next problem. Pasha loves prime numbers. Okay, that's great. So, wow, is prime number sexual? Haha. Once again, in his attempts to find a new way to generate prime numbers, he became interested in an algorithm found on the internet. Obtain a new number y. To obtain a new number y, repeat k times the decimal representation of x without leading zeros. For example, 52 and 3, you get 52, 52, 52, 52. Okay. Pasha really wants the resulting number to be prime, but he doesn't know yet how to check the primality of number generated by this. Okay. Okay. Right. So basically, I think for all even numbers, it doesn't work. And then, you repeat any number multiple times, doesn't that become a multiple of right? So if it's like a two-digit number, okay, let me check. Right, so if it's an n-digit number, and if I sort of repeat it multiple times, it can be done by, like, let's say this number is xyz. So if I do xyz multiplied by 1, and then I think double zero, 1 0 1, something like this. If I multiply this by this, then the result that I will get is z y x, and then again z y x and z y x. So yeah, if there are multiple digits, I think you can always like this would always be a factor. But if there's a single digit, you can't do something like this, right? So if I have a number like I don't know, 777, oh, then again I think this is a factor, right? So I think the only prime numbers that we can get this way are some consecutive ones, like maybe 11 is prime. I don't know if 4 ones are prime or 5 ones are prime. I don't know. Some of those might be prime, but like I think that's it. Nothing else can be prime. Yeah, exactly. So the only way you can get a prime number from this is right. So you just need to have ones followed by something. Except if you have, I don't know, maybe tens followed by something. If you add something like this, does it have a factor? I think it's just 1 in itself. I mean, obviously, since it ends at 1, since it ends at 0, let's say it's even, so it's not prime. But like, what if it was odd? Like, what if it was 1 1 repeated multiple times? Right? So then, can we still do it? I think if k is not a prime number, then we can break this down into multiple buckets. Like, you know, if like k is 6, so we have 3 buckets like this. And then again, we obviously can divide it by 11, because we get 1 0 1 0 1, I think. Yeah, multiplied by 11. Right. But is it correct that we need, I think, wait a second, is k ever 1? Yeah, okay, so if k is 1, you have to do proper primality test. If k is not 1, then you can always get a factor like this. There are some exceptions if you repeat 1 multiple times, right? So repeating any number k times itself gives us a factor, something like this. because this can repeat, any number, like any 2-digit number 3 times, and then you can repeat any n-digit number k times by doing something like this. So for any multiple digit number, repeating it multiple times will never give you a prime number. But for a single digit number, it might be possible. But for any digit other than 1, that digit itself has to be a factor. So like the only case when k is not 1 and the number can be prime is if the number is 1. If x is 1, okay, and then it's a simple primality test. Okay, so I need some sort of is prime, bool is prime in n. So I want to check if n is prime. Simple, actually. I need to just see if there are any factors that are greater than 1 till square root n. Okay, now I think if n mod I equals 0, then I can say return false, otherwise return true. Oh, sorry, then return true, otherwise return false. Right? So for 1 is not prime, then 2 is prime, or what? Wait a second. I think it will say that 2 is I'm glitching. It will say that 2 is not prime, right? Because this will fail. Oh, sorry. If we get any factor, then it's not prime. Otherwise, it is prime. But what happens for 1? If n equals 1, then we have to return false. Okay. Right. So if it has any factor for like 1 is not prime, and then for any other number, I can check from 2 till root n. If there are any factors, then it is not prime. Otherwise, it is prime. Okay. So yeah, I'm surprised I took so long to do a simple primality test. I guess that's what happens when you're out of practice. But yeah. So if x not equal to 1 and like k is not equal to 1, right? So we can just say no. Right? Otherwise, while k is while k minus minus, I can just do my number into n equals 0. Let's just make that number. So I'll just do n equal to 10 times n plus x, right? So like if k is 3, I'll just do this 3 times, so I'll get 1 1 1. I think there's no need to do that. Yeah, so now I just have to check if it's prime. If is prime n, like if you can see if k is 1, then n equals x. Right? So yeah, now if it's prime, then I'll just say yes, otherwise no. I think in some cases test cases. Okay, works on local. Let's submit. TBD table. Wow. Genzi Ringo has reached Codeforces finally. That's great, I guess. Is this wrong? Okay. works. Anyway, so now I have KBD table something. A table of 2 cross 2. There is a lot of input here. What is this? Wow. Looks like a lot of input. I have to read what's going on. Okay, so let's take, for example, a table of 2 cross 2 with rows numbered top to bottom, columns left to right. We place 1 in 1, 2, 3, 4. Okay. 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 Right. 4 equal square tables, right? Followed by the bottom one until he reaches table of, okay. What is this? Top left, then bottom right. Okay, I think, right. 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And after these 16, you fill these here, then here, then here. 1, 2, 3, 4. Okay. Right. Right. Let's see what's going to happen. What's the question? Okay. There can be, I think, 2 types of questions. Like what is in x comma y and where is a d. Those are the two types of questions that we have. Okay. Okay. Right. Right. Okay. Let's clear this thing. So immediately I don't have any idea about this. I do have some intuition that we can, maybe, I think we can kind of just figure out in which cell we need to go, right? So we have a big square, then inside that there are smaller squares, and then inside that there are even smaller squares. Let me make it with a different color. Yes. Right. So I think the query in which they ask where will, let's say, 35 be present. They ask 35 is where, something like that, right? So I think I can just do so like there will be ranges. So like this first square will be some A to B, then this will be from B plus 1 to C, then this will be from C plus 1 till D, and it will be D onwards, right? D to, let's say, E. And I have to quickly find out in which square do I need to go, and from there I think I can continue in that direction itself. Like if I'm in this square, then I can do the same thing again. All I need to know is the range which this kind of contains, and like for the base case, the range is from 1 till 2 to the power 2n, or 4 to the power n to be more precise. And then it gets divided into like 4 parts, right? So all I need to do is see in which part we're going and keep a track of that range. This is the A and this is the E, and then we can again divide it into 4 parts, and I'll always be able to divide it into 4 parts without getting any fractional value. So that works, right? Because I think in this example you can see we have up till 16, so we can easily divide it into 4 parts. I can get like from 1 to 4, 5 to 8, and so on. I think the second query is easy, like 35 is where, that's easy. What about what's present in x comma y? Right, so I think that's also kind of similar. We have to see like in which basically there are four ranges in which like I have to go into one of these four ranges, and like that's all I have to do, right? I just have to check in which range is my x comma y present, and yeah, based on that I can sort of like, I think it's just the opposite. I have to keep track of the um like instead of keeping track of the, like I have to keep track of this range, right? Whenever I descend into some, I think I also have to keep track of the indices, like which row and column are there, right? So I think that's all we have to do. Whenever we descend, we have to. I think in both cases, I just have to keep track of what's my range, and also what's my, like what's my value range and what's my coordinate range. I think those are the three things that I have to keep track of, like value range, x coordinate range, and y coordinate range. And I think based on that, I can always decide in which quadrant I have to go. And yeah, I think based on that, I can do the rest of it. Okay. So it shouldn't be too hard. Let's try to figure this out. Okay. Implementation wise, I think it's not like super trivial, but should be really doable. I have int n, sorry, int n, also q. I have n in q. Okay. Now for each query, I think I have to do the same thing for each query, right? Okay. So I need the initial range. Let's say L is equal to 1 and R equals 2 to the power 2n, right? Two to the power 2n, which is actually 4 to the power n. So I can start with, I think, 1, and then I'll make it 4 to the power n. So int equal to n, while to minus r equal to r times n, r times 4. I think now we'll get it. Let's even check whether this will work. I mean, obviously it will work. Yeah, so for the first case it's 16, so it's working. Anyway, now right, so my range is from like L to R. So let's take the queries. In each query, I think I have a string, then to string type, int type, if type equals, I think this one, then I'll do int x in y. Otherwise, I'll just do int b, int d. Okay, right. Now let's try to solve it for this one. So my range is, let's say, L to R. Okay. Right. Now I want to descend into this range in such a way that I can always keep track of the D, I guess. I also need to keep track of the XY range. So I have like XL equal to how many are there? 2n, right? So from 1 till 2n, and then YL is also from 1 till YR to 2n. Wow. Okay, so while descending, I have to keep track of all these, right? So I'll just do while L not equal to R, I guess. Descended to a single cell. Right, so while I'm not in just a single cell, I need to decide where I need to go. So how will I decide where I need to go? It depends on the D, and I can sort of divide it into 4 parts, right? So I think I can just do divide. If I do divide by 4, do I get the quadrant in which I need to go? 16 minus 5 is 4. 16 minus 16 is 0. Okay, I think if I subtract 1, wait a second. Sorry. If I subtract 1 to all of these, then it's just from 0 till 0 till 15. If I divide those by 4, I get from 0, all of these will be 0, all of these will be 1, all of these. Yeah, I get from 0 to 3, right? So just do value minus L by 4 by 4. And then I get I can just simply split the range into 4 parts, right? So I think interval equals R minus L by 4, right? So now the intervals are like L comma L plus interval minus 1, right? Yes. Okay, and then L plus 2 times interval minus 1, and L plus 3 times interval minus 1, I guess. I have to add 1 here. Right, R plus 1 minus L works. Right, so if I take this and also L multiplied by 4 times L plus 4 times interval minus 1, and this is just equal to R. Call it I still. Right, so I think these are sort of the ranges. Like this is one of the ranges. And then the next range will just be from L plus I till this one. Sort of open intervals we're having. And then this one will be from L plus 2I till here, and so on. L plus 3I. Yeah. So these are the 4 ranges in which it can be, and based on that I have to descend into that quadrant. Right. Okay. I need to check in which of these it is present. I think if I subtract L from all of these, it's just from 0 till I minus 1, then right, and then I think if I subtract I from it, I get 0, 1, 2 or 3. So I'll just do exactly what? Yeah, I just have to do d minus L divide by this interval, right? So this will be the next ID sort of thing, and it's in the range 0 to 3. Okay, so based on this, I have to decide where I need to go, right? Okay, okay. So my new range will be, I think this should be easy. New L is just L plus next ID times interval, and then new R is nothing but L plus actually these are all closed intervals, right? It's just next ID plus 1 times interval minus 1, right? L plus 4 times interval minus 1, yeah, works. Okay, so I get my new L and new R based on the next ID, and I also need the new XL, new XR, new IL, new IR. Int new XL, what will this be? I think it depends on where we are descending to. So like if it's 0, then both of them will get half. Like both of them have to get half. Then if it's 1, then both of them are in the second half. If it's 2, then do we need some sort of switch case here? This is bad. What I know is that I can sort of reuse a lot of this stuff here itself, here as well, right? So for the X interval and Y interval, both are just XR minus XL by 2, I guess, plus 1 by 2. 4 minus 1, 3 plus 1, 5. Yeah, okay. I'll just call it the C interval or the coordinate interval. It's XR minus XL, XR plus 1 minus XL by 2. Okay, now here also we have ranges, so let's just say these are the same. Okay, now if the next ID equals 0 or next ID equals 2, then in both of these cases I will just do new XL will be XL plus new XL will stay XL, and new XR will become XL plus the interval, I guess. XL plus the interval, plus the C interval. 1 plus 2 is 3 minus 1. Okay. Really need to keep track of all the off by 1 cases here. Like we can fuck it up. I think then XL has to be this, and this will just say XR. Okay. But we have to do the same thing for like the YL YR. Anyway, so if next ID equals 0 or next ID equals 3, then in both these cases I have to I think new YL will just be YL itself, because in both 0 and 3 the Y is not changing. Wait a minute, which one is Y and which one is X? First example, for the second question, the answer, for the third question, the answer is 1, 2. 4 is present in 1, 2. X is 1 and Y is 2. So Y is this one and X is this one. I might be doing the exact opposite here. I think I'm doing the exact opposite, right? So I have to keep X less, and X is this thing for 0 and 2. Yeah, works. Okay. And then new YR is just XL, sorry, YL plus C interval minus 1. Otherwise, I think it's the same thing. New YL is just YL plus C interval, and new YR is just YR. Okay, now we have to make the changes. L equal to new L, R equal to new R, XL equal to new XL, YL equal to new YL, XR equal to new XR, and YR. Maybe a recursive way might have been slightly better here, but I don't know. Okay, so when we escape this loop, we are just left with XL equal to XR and YL equal to YR. So we can just output Cout XL space YL \n, right? And in this case, for now, I'll just say, I don't know, see the rest is correct or not. Okay, doesn't seem right, I guess. Oh, sorry. So I'm outputting 3, 2 instead of 2, 3. I think in all cases I've swapped these. So this should be easy to fix. I'll just do this thing. Okay. Right, now all my answers are correct. Right, works. I think I can just copy paste this thing exactly, and now all I need to do is figure out the correct next ID. I paused it there for a second. It's some work. Anyway, come back. I think I can copy it exactly. The only difference will be that here I will just see out whatever my L is, right? Because we're descending in that way as well. One problem is that there's no D here. So the next ID has to be calculated in some other way. It has to be calculated, I think, based on the C interval. There might be 4 cases Doesn't sound too good, but we will have to do it. Right. So we need to figure out the correct next ID. Okay. Right. So let's do next ID x equals something like x minus xl divided by c interval, and then next ID y will be y minus yl divided by the c interval. Okay. So now this is 0 to 2, 0 to 1, and this is also 0 to 1. And we need to make 4 cases to get the actual next ID. I think it's like if next ID x equals 0 and next ID y equals 0. We can actually make 4 cases, I think. We can do int temp equals next ID x multiplied by 2 plus next ID y. For all these 4 cases, we can get the correct next ID. If temp equals 0, I have, let's say, next ID equals 0. So I need the correct values here, right? So this is 0 0, this is 0 1, 1 0, and 1 1. Okay, for 0 0, my next ID is 0. That's correct, I guess. For 0 1, that is if y is 1, if y is 1, then it's 2. If x is 1, then it's 3. X is, wait a second. X is 1, then it's 3. And for this case, it's 1, I guess. Yeah. I think that's it. Okay, something seems wrong. So I gave 8 instead of 7 for 4, 3. Oh, 4, 3. Did I mess it up again? I gave 8 instead of 7. The reflection. Is it the opposite? Is it 3, 2? Wow. I'm not sure if this is correct though. This being 3, that means y has to go in the second. I think like in these cases you'd rather take one penalty instead of spending hours to debug. If it's wrong, then it's wrong. Let's just submit. It's one of those ugly implementation problems. If the answer is wrong, I have no idea if I've messed up the order or if the logic is wrong in some way. Runtime error, wow. Runtime error, runtime error, runtime error, runtime error. How would it be a runtime error? Let's see. Am I ever dividing by 0? This is bad. This is bad. This is very bad. This is bad. It's weird that it worked for the first test case. Anyway, let me try with new test case, I guess. Let's say this was 1 and 10. I have one query. I need, there's one. Yeah, one. Wow. In 1 comma 1 I have 1. Yeah, makes sense. What I have in 1 comma 2. Yeah, this is wrong, right? Yeah, all of these are wrong, definitely. Definitely wrong, definitely wrong. Okay. It's the opposite though. Something like, where is 3? No output? Is that no output? Oh, sorry, two queries. 3 is present in 1 comma 1, that is also wrong. Where is 1 present? Also in 1 comma 1. Wow. Definitely I'm doing something wrong. So what I can do is, I think I can just see out all of these. L, then R, and XL, XR, YL, YR. Decrease this to a manageable number. Right. I think it's easier to debug this second case. So I'll do that instead. Okay, this is wrong. I have the wrong number of rows. This is not 2n. This is not 2n. This is, I think, 2 to power n. Okay. It has to be 2 to power n, 2 to power n. I'm just writing it TPN because it's 2 to power n. Okay, this looks better. This looks better. Let me check. So in 2 comma 1 we have 3 and 3 is in 2 comma 1. Okay, it should work. Tough implementation, at least for me. If you were able to implement it in a simpler way, like, let me know in the comments. I think the mistake that I did was I took xr equal to 2n. I thought there are 2n rows and columns instead of 2 to power n. Yeah. Solution is just like wow. So all this part is okay. So it's kind of like in both the queries. So it's a recursive kind of structure actually. So like whenever you for both the queries, the same part. Yeah. So for both the queries, you can see whenever you are in a square, like in the beginning you're in the whole square, after that you'll be in a smaller square, you will have 3 ranges. So the 3 ranges will be your value range, and then like X range and Y range. So you just need to descend into these squares while keeping track of these ranges. So if you know the value, you can get the X and Y, and if you know the X and Y, then you can get the value. You just have to descend to the correct range. So like you have to figure out if you're here, then there are these 4 smaller squares, and you just have to see in which one you need to go, and that's what I have. For that I have this variable named next ID. In both cases, you have to find that variable. Basically, finding that variable is the thing that's different in both of the queries. There's different logic. Like for one, you have to divide the value range into 4 parts, and for the other, you have to divide the X range into 2 parts and Y range into 2 parts. Based on that, you have to kind of figure out in which quadrant you need to go. And after that, you just need to do the transitions to get the correct new ranges corresponding to that quadrant. And that's all you have to do. And you're like, once you're done, you're in the correct quadrant, you know basically what's the value range in this quadrant and what's the X coordinate range in that quadrant. And based on that, you can print the correct coordinates or the correct value based on whatever is being asked. Then finally we move to the next problem. How many submissions for this one? 2000. Wow, I'm surprised 2000 people were able to, you know, do that sort of implementation. Like I'm just doing it for the video. I probably would have not done it otherwise. Like, or else there might be a simpler implementation. Maybe I missed some. Maybe there's some, you know, easier way to see like 0, 1, 2, 3. I don't really know. 0, 1, 2, 3. Like, you have to kind of, like, you can't just get it, you know, from, like, you have to do some if else to know which is 0, which is 1, and so on. Like, it can't be too trivial. That's what I feel, but like, not very sure. And there's a big scope of doing off by 1 errors in this. So I really don't think ChatGPT can get that right. Like, I'll probably try it later, but I don't have premium, so I don't know. But yeah, there's a lot of off by 1 errors that are possible, and you have to, you know, do a lot of casework. Not a very nice implementation, but I think it will help you if you're like bad with implementation. That the type of problem that was. But yeah, anyway, so now we start with the E problem. So we have an array of length n, and we also have a number k. The subarray is defined as one or more consecutive elements. Okay, to split into k non-overlapping and union. So you have to partition it into k parts, and then if we want to maximize x, which is the minimum of the max. Okay, right. So we have to divide it into k parts such that the minimum max is maximum, and max is itself the minimum minimum number that is not present in the array. Okay, so values are large, arrays are large, everything is large. One thing that I think can help us is that the max is kind of never, max can never be greater than the size of the array, right? So if you want the minimum of the max to be 10, then all of the arrays have to be at least 10 in size, right? Okay. All of the arrays have to be at least 10 in size. Okay. I think if k is greater than the square root of n, then I think it's then what will happen if greater than square root? Like, we have 1000 and we have to make, I think basically the answer can never be more than the square root, right? Because if we divide it into square root parts, then each part has to be smaller than the square root, or like at least one of the parts has to be smaller than the square root. And yeah, so basically for an like, if we make k partitions, then the answer can't be more than n by k. So I think so I'm getting that idea, like, you either do it in O of k or you do it in O of n by k, something like that. That's my intuition here, but let's see. Wait a second. So do we need to solve the subarray max problem here? Plus, is it even easy to do subarray max? Like, I think it is done using segment tree, but that seems like an overkill here. In general, if you think about subarray max, I think it will help us get some direction about how to build a solution. Right. Okay, let's say I want the max in this range. 0 to 3. Then the max is 4 if I have bigger values. Okay. So better max is not trivial. And probably we won't need it for this problem. Like, that's what I feel. We shouldn't need it for this problem. Like, this is just a div3e. So subarray max is not trivial. Subarray max is not trivial. I hope. I think what we can do is we can go like a scan line sort of thing. We can keep the last occurrence of all the numbers in a segment tree of NVIC tree, right? And then till here we'll check the first element in this segment tree, which is smaller than this thing. So we will descend on the prefix min. Yeah, you definitely don't have to do that. Okay. Right. I think it's sort of like a binary search. Can we make the max at least some value? I think that's what we need to do. It should be a binary search. Can we make the max at least 10? Like, let's say that's the question. Okay. Right. So I think it's just basically like to make the max 0, it's very easy. Just make any partitions and you're done. To make the max 1, you have to give a 0 to all of the subarrays, and then to make the max 2, you have to give both 0 and 1 to all of the subarrays. To make the max 3, you need to give 0, 1 and 2 and so on, right? So is it greedy? Like the moment I get 0, 1 and 2, I end that partition there itself. Is that what we need to do? Because like, what's the advantage of taking any extra elements? I think it's just binary search and then greedy on top of that. Yeah, I think it's simple. It's simpler than I thought. It's just binary search plus greedy. Okay. Okay. So I have this. Okay, now, right, len L is 0, R is I think maybe n plus something, n plus 2 or something, when that is not possible, but yeah. While L is smaller or equal to R, well, while L is smaller or equal to R, okay. Just standard binary search. Now I just want to see whether M can be whether the array, whether the max of the array is at least M, right? So I want to, I think, make this from 1 till, okay, right? So I want to incorporate all numbers from 0 till M minus 1, right? So we'll just do vector int I just have to check whether all are kind of found. Okay, right. Make a vector of size, okay, and then size M, then all of these are 0, right? And then we also have num found equals 0, right? This is just like a set or something. So we can even see how many partitions we can make this way. Right, so every time I'm able to do this, I'll just increase the partitions by 1. right? Actually, I can make it a set itself, but then it will be log square. Log square will work, maybe. Set this off. Okay. Should work. Let's see. So now I'll just iterate the array. Can even do it like this. Okay. Now if x is smaller than m, I'll just do s dot insert x if the size of s is equal to m. If I have all the elements, then I'll just do numparts plus plus s dot clear, right? Now if I'm able to make k parts, if numparts is greater or equal to k, then obviously this can be the answer, and I want to find something even larger. Otherwise, I want to find a smaller answer and just see out the answer. Should work. Big term. Okay. Oh, sorry. R equal to m minus 1. Right. Okay, past. I think my only concern here is that I have used, like my only concern is that I have used a set here. So this is log square. I want to avoid that. So I'll just do vi found m and then int num found equal to 0. Okay. Insert will be like if found x equals 0, then found x equals 1, and num found plus plus. If num found equals m, then instead of clearing, I think I can just do equals vim. Right, so it seems like it can go n times m, which is n square, but it can never go, I think, more than, like, basically after finding m elements, we are resetting m elements, so it's just linear, kind of amortized. Should work. Is it an infinite loop? Failed. I think I just didn't do num found equals 0. That was the problem. Should be fine now. Right. So this small trick makes my solution linear instead of quadratic. Sorry, a linear instead of n log n. Like actually n log n instead of n log square n, because I removed the set. I think this one was also kind of self-explanatory. It's just binary search, and like way you divide, like the moment you get all the elements smaller than the required max, you can divide it there, and you need to make these many parts. Yeah, I think this was simpler than D, at least for me. Okay, now we really got to pick up the pace because only 50 minutes are left, and we have two of these problems, and these are the toughest problems of the contest, so we need to be fast. Okay, neural network. Wow. Okay. Wow. This is a long statement. I don't feel like reading it. Oh wow. Like when the statement is long and I don't feel like reading it, first I see the example to kind of try to grasp what's going on. Then I see the input, like what are things are given to us. Then I read the statement. It helps a little. So I'll have n and m, then I'll have n strings, and then n more strings. Okay. Sorry. First n strings and then n times m more strings. 4 and then 4 times 1. Right. Right. Okay. Okay, that's the input. Now let's see what's going on. So we have an array. They want to get array A. They have C, it's filled with blank. The length is same as A. They have M neural networks, each of which has its own version of answer to their request. Okay. The hackers are trying to obtain array A from the array C using the following operations. We'll select a random blank, replace, choose I, random blank. Okay. Okay. They can put a blank anywhere, or they can take any blank and like choose one of these strings and copy one. I'm not sure what's going on, but yeah, let's read the full problem once. Because of the way hackers access neural networks. This reminds me of I think ICPC 2021 or something. Very bad statements. I mean, very long statements. I don't want to say bad because people put effort to make these, but yeah, bad for me. I don't like reading long statements. Okay, so because of the way hacker modified, okay, so they will have to specify the entire sequence of operations in advance. The random behavior may lead to situation is never obtained or okay. Therefore, the hackers are counting on your help in choosing a equation that will guarantee. Wow. Guarantee. I think it should be usually impossible. Wait. It should be usually possible actually. Got it. I think what you have to do is like first fill all the positions with anything, then like not with minimum operation, but like this is one of the solutions. Like first fill all of these blanks using okay. Okay, I think if you perform this first operation n times, then all the blanks will be filled, right? After that, what you can do is you can make one of those blank, and then if you give the correct neural network, then you'll get the correct value there. So I think that's what we need to do. First fill all the blanks using n operations. Once all the blanks are filled, one by one go through the array. Wherever all the all of these columns are not equal, you can you need to remove those, and then do we have to just put the number of operations? Just remove those and then do one more operation and we're done. Right. So I think the first step is to check whether it's possible, and it's always possible. It's only impossible if this word is not present in any of the columns. Okay. It's a simple problem, but a long solution, a long statement. That's it. The problem is simple. Okay. Right. So I have n and m. Then I have a vector of string named a of length n. I input a. And then I have another vector of string of length m comma n. Right. So right, so I have all the inputs now. Right, so answer should be equal to n times. You need to do that. Then at every place you need to sort of do 2 operations to get the correct value. 2 times required columns. Right, and then that's your answer. Right. Now you need to sort of go through all the rows. Now, if none of them is equal to, if no b j I is equal to ai, then you have to output no, I guess. Right. So I think for every column, first we need to make the set of that string. Okay. Now, if AI is not present in this set, then it's impossible, right? Right, because if AI is not present in this set, you'll never be able to get it. And right, your required columns are 0, and if s dot size is greater than 1, then required columns plus plus. Because if the size of the set is 1, then even randomly the just a second, actually this is also wrong. We actually kind of need to, I think this part is right. Answer is something else. Answer equals to n plus 2 times different, right? And different is, I think we need to find the number of common for each, and then the maximum of that, and something like that. Supplemented them. How many are common with this, with n? Okay. Right, so now I know how many common I have. Right, so I want max common. Right, now I have the max common. So different is just n minus the max common. This should be the answer. Okay, should be right. Okay, I think the idea here is that the idea is quite simple. I think we have an array with some values. Like, if to simplify the problem, we have some array with some values, and then we also have another matrix with some other values, right, with the same number of columns and possibly more rows or less rows, I don't know. Right, so like there are some other values here like this, and some can be different, some can be same, and so on. Anyway, so basically what we do is we can choose one of these rows, and then it will randomly pick a column and fill this value there, right? So the like one of the ways to and we want to get a desired string at the end. So one of the ways to do it is that just pick the first row n times, and then this will be full, and then you can use this second query, this basically the second operation, to make any of these positions a blank, and then like once you make this a blank, you can pick one of the rows where this value is same, and then randomly this column must be chosen and this value will get copied. So this way at first you'll pay n operations and then 2n operations more. So in 3n operations you'll be able to do it, but that's not the minimum, because the minimum will just be dependent on like, so as I said, you can pick the first row for the first n operations, but you can also pick the second row for the first n operations, maybe the third row or maybe the fourth row, right? So like it depends which row you're picking. So which row should I pick? It should be the one that has the maximum common cells with this array. So that's what I've done in the code as well. Just see what's the maximum common, and then the different will be n minus the maximum common, and for all the difference you need to pay two operations, one to clear it and the other one to copy it, and then these n operations to kind of randomly fill the values, and the max common will automatically be correct. So yeah, that was that. Oof. 1000. Okay, now this last one is remaining. Shorten the array. Okay. The beauty of an array, at least this statement is shorter, so I'm happy. The beauty of an array of length m is defined as the max of the XOR of all possible pairs. Okay, we know the beauty. I think max XOR is an easy problem, so it must be something else. Max XOR is, I think, just try. Yeah. Okay. Now, and you can expect try in div 3G. Not sure. I haven't done these contests in the last maybe 2 years or something. But yeah, we have 30 minutes for this problem. I don't know whether we'll be able to do it or not. 30 minutes for a div 3G. I should be able to do it. But yeah, anyway. So An array is called beautiful if the beauty is at least k, I guess. Okay. Recently, I don't think it's about finding the beauty, it's about making an array or something. The inputs are n, k, and the array. Okay. N, k, and array. We have to make some changes to make it beautiful or what? Okay. Cut out some beautiful sub array from it. Okay. Your task is to find the length of the shortest beautiful subarray in the array A. That's it. Length of the shortest beautiful. Okay. Wow. I think for each element we just need to find which element on its right, which earliest element on its right can kind of give you the beauty at least k, something like that. Then we will get segments of sorts, and then we need to kind of find the smallest segment, right? We just need to find the I and j itself. If I clear this, right? Well, I hope it's still recording. I paused it in between. I hope it resumed. Anyway, so I have an array. Let's say for this element, if I try to find the nearest element such that the XOR is at least k, then I can kind of do it, right? So for every element, find the nearest. I think the question is just for, or even on the left also. For every element, find the nearest element such that the XOR of these two elements is greater or equal to k. That's the problem. Now, can I solve this with a try? Let's say if I had a try here. If I had a try with all these elements, can I find the greatest index which can sort of give me a value greater or equal to k? I can also maybe find a range of elements which will give me that value. I can find, maybe I can find like 32 ranges. So if I don't want to implement a try, maybe I can do something like get the bitwise representation of the number, something like this, and then I get multiple ranges. Like one of the ranges is like just make this bit 1 or make this bit 0, something like this. Like for each bit I can sort of get what's the range. No, I know this number and I also know k. Let's say this is what I want the XOR to be, right? So then what's the range? So this is 0. If I change this, then it works. If I change this, then also it works. But I must change this one, right? So I don't get any range here. I must change this one. I don't get any range here. I can change this one, so I get a range here. But yeah, that's more tricky. Yeah. Let's think it in the try direction itself. I think the try direction is also same. It's like to get the max XOR, I want to descend in a certain direction. Not max XOR. To get at least K XOR, I need to like, it will generally be like either take this entire subtree or go inside this, or like you must go inside this. So like when you can take this entire subtree, it's just that you need the maximum index in this, right? So I just need a try that stores the maximum index of the subtree, and I can take any subtree, something like that. So that's the solution. Like, now I'm not sure if I'll be able to quickly implement that, but yeah, that's the solution. I have to check if I have a snippet for try. Do I have a try snippet? I don't. Right, I don't have a try snippet. So then this won't be too easy. Otherwise it would have been very easy if I had a try snippet. But yeah. Okay. So I need to make a try on my own. A bitwise try or something like that. But yeah. I don't think it will be too hard. So I have N and K. Right. So the solution is very simple. It's just, I think, so go to all the indices, right? Then just insert it to the try along with the index, right? And then get max index such that to get max index such that the XOR with X is at least K, right? So insert get max index. Now if J is not equal to -1, answer equals yes, n plus 1. Now if answer equals n plus 1, I can just make it -1. Right, now answer is just min of j minus I plus 1. Right, now these are the only two functions that I need to implement. Also a clear function, I guess. Clear, try, get max index, and insert. These are the only three functions that I need to implement. Maybe like this. Right. Okay, 32 bits and then 32 times 10, something like that we have to do, I guess. Right, then there's insert. I'll have to see. I'll have to see what type of structure I need. But yeah, I'm not so sure how tries work. I mean, I know how tries work, but like, you know. Okay. Values are till 10 to the power 9. I think 2 to the power 30 should be fine. Okay. 2 to the power 30 is how much? Yeah, works. I think even 2 to the power 29 will work. Okay, value comma index. Okay, now, so what I need to do is I need to store in each node what is the, in each node I need to store the maximum in that subtree, something like that. Okay. Anyway, so let's say b equals 30 for int b equals b minus 1, b is greater or equal to 0, b minus minus, right? Now if val machine b and 1, that means this bit is high, the y is low. I think I just need the bit. Okay, so now from here I need to go to the left or right based on this, right, to 0 or 1. Right, I need a root. So root is the 0 node. I think I need to make a structure of the nodes. I think something like this. And this is a vector of the nodes that I have. In one node I have node star, int left and right. Something like this maybe. Let's say the root is like no node is ever 0. So I start off with the root. Okay, so I have try curve dot next bit. Right. Right. Now if not next, then I'll just do next equals alloc plus plus. I think alloc equals 2 should be fine, or root plus 1. Okay, now car equals next. And I have max ID. This will be the ID that I've given, right? So this way I think insert it into the try. Okay. Will this work? Not sure, but yeah. Now I just have to write the get max index. How much XOR I need, and yeah. Again, I'll start it from here. And I'll do this. I think I missed one thing. Okay, now I need to know the bit. Right. If the XOR bit is high, then I do something, otherwise I do something else. Right, so if the XOR bit is high, it's like must be different. It's like can be same. Okay. All different work. Right. Right. Have to go to the other bit. I think we have to break here because I think nothing is left inside this subtree, and we can go nowhere. We'll never be able to get an answer from this. So we break. Otherwise, I think it's just cur equals next, right? In this case, all the difference work. Right, so in this case, all difference work. If it exists, I can go into that subtree and take any value. I can take any of these. I'll just return answer here. Right, then can be same. So the same part is the tree that will descend. Right, so we have the same is the next. If it's 0, then we have to break because we can't descend in this direction. And yeah, we go to the next. Ultimately, at the end of this loop, two things might be happening. Either we are at the position, either we are at that exact value, and then we have never done this, right? Or we broke somewhere in the middle. How do we check that? We can just do, I think, both these cases we can do equals 0, right? Now if that means reach the leaf, and then this is the leaf that we kind of wanted to reach. Anyway, so we'll just do okay, should work. I think XOR is some keyword. XOR is probably not a keyword. I've made some mistake. Oh, semicolon. -2. Wow, this is funny. Can never be -2. Okay. Okay, these two are at least right. Okay, this is also right. I think this one is wrong. I know I can just hard code it for this case, but I want to see where it went wrong so that I can be sure that my try is not wrong. I have 10 minutes, I'll figure it out. For 0, it gave -1. Why? Why? This is wrong. Should always come here, right? I think the problem is how I'm inserting the. Is there some issue with the try? if we had like just 2 bits. I'm running out of time. Okay, now right. So I just need. I think I can hard code this case and get away with it, but I don't want to do that. Right. Got it. You have to insert it before checking. That's it. I think there's nothing wrong with the try. Then this was the problem. Like you can, yeah, you can work with the same element also. I hope it's right because I don't have a lot of time to kind of debug it. Wow, no, this is not right. I have no idea how to do it. There's nothing I can do now. There's not enough time. Just making sure. Max of Zors. I'll just take those two elements. Like it's obvious. It makes sense. I just need those two elements, and I need them to be as near as possible. So the Zor that I need is K. Just iterating the try. Can this be wrong? If this orbit is high, then that means they have to be different and we cannot get any answer right away from here. But if this orbit is low, then we can take any different. If that's not zero. Right. And yeah. I don't see what can be wrong here. Mm. Is that the case? Wow, what the hell? Ah, I think the numbers were too big to fit in that. 2 to the power 29 is not enough. 2 to the power 30 minus 1. I don't know. I don't know how it didn't fit in that. Wow. Okay. I think the only problem was that. Sorry. Yeah, I think the only problem was this thing. Instead of 30, I'm starting from 29. So 2 to the power 29 is big enough, right? Yeah, I'm not sure why. Like, are the test cases right? If AI is up till 10 to the power 9, then all numbers should fit. Just to test, let me just check. If x is greater than, let's say, okay, 10 to the power 9. Then I can just say it through. I really want to see if the test cases are wrong here. So let me submit it once more. I know it will increase my penalty, but let's see. Oh no. Oh no. I made a mistake. I don't know what it was. I don't get it. 2 to the power 29 should work, right? About 29 plus everything. How is it not working? I have no idea. But anyway, I got accepted, so fine. I have made some sort of miscalculation, right? What is it? This was 30 and I started with 29. Like, 30th bit is never 1, right? So how is it wrong? I don't get it. But yeah, that's the whole problem. You just have to make a try. Insert the values, get the max index, and you get your answer. Like, that's the whole problem. All you had to do was implement a try that can do all this. Now I did that. Some people have snippets and they can do it automatically. So anyway, I'll just go and upload this video now so that you guys can watch it. And yeah, thank you for watching. Please subscribe to the channel.